So our given function is that when we simplify this, we get x. Yeah, I don't need to say it right. We x 2 minus x minus 1, x minus 1. Then to find our domain, we know that the denominator can't be equal 0. So then we make the denominator equal 0 to find where it can't equal 0. So then when we simplify it, x minus 1 squared equals 0. X can't equal 1. Therefore, it means the domain is x is an element of real where x is not 1. And then our intercepts then, making y equals 0 in this equation, then we'll have to make both sides equal to 0. Looking at this, we can see that if we make x equal 0, it'll be x, it was 0 times something, and 0 times anything, 0 times something is 0, as we have there. And if we make x equal 2, it'll be 2 minus 2, which is 0. 0 times something is 0. So we know that our intercepts are 0 and 2. This is my proof here. Then the y-intercept we've already found out is 0, because when x was 0, y was also 0. So there we go. Symmetry. Now to find symmetry, we know that this function is an even function. It's not an even function because when we make our x a negative, it does not equal our original function. Therefore, f of x is not equal to f of x is not equal to f of minus x, and it's also not equal to minus f of x. Now for our critical points, we've already shown here that x cannot equal 0, and that is our only critical point. Now for the asymptote, since we know x cannot equal to 1, we find the limit as x approaches 1. And when we sub 1 into our equation, we get 1 over 0, which means the limit is infinity. That will be the vertical asymptote. And to find the horizontal asymptote, we find the limit as x approaches infinity. When we sub infinity into the equation, we get infinity over infinity. We can't solve that, so we use L'Hopital's rule. Using L'Hopital's rule, we get the derivative of the function at the top over the derivative of the function at the bottom, which is 2 minus 2x over 2 minus 2. We take out a negative, which then allows us to cancel these two, and we get negative 1. This is the horizontal asymptote. Now, using all that, we can plot the vertical asymptote, which is 1. Vertical asymptote is 1 because it approaches infinity, positive infinity as it approaches 1, so it's an asymptote. The horizontal asymptote is negative 1. Y-intercept is 0. Okay. X-intercept is 0 also, and our second x-intercept is 2. So then, using our points, we know it tends to infinity as it approaches 1. So from either side, it will tend to infinity, crossing at at 0. And then as it approaches infinity, negative infinity, the asymptote is 1, negative 1. Same on this side. Asymptotes at 1, and then it cuts the x-axis at 2. 2. It looks something like that. Sorry for the shape. And yeah, that's basically it.